Friends, today we are going to see the next topic of this unit 1 of the paper 1. Solution is nothing but the homogeneous mixture of the two or more component that may come for the MCQ. Aqueous solution is nothing but a solution containing water as a solvent is known as the aqueous solution. Concentration represents the amount or say volume or chemical units of one component that may be the solid associated with the definite volume or amount of the other component that nothing but the solvent or say solution. Different methods are used for the expressing the concentration of solution. There are the physical unit and the chemical unit. Two basic headings are there. In the physical unit, they are generally expressed in terms of the percentage composition by the weight by weight, weight by volume, volume by volume. Weight by weight is nothing but a W by W, weight by volume is a W by V, and volume by volume is V by V. In the chemical unit, there are the two subcategories, volume basis and the weight basis. On the volume basis, there are the molarity, formality and the normality. And on the weight basis, there are the molality and the mole fraction. First of all, we will talk about the physical units. Generally, the compositions are given on the basis of the percentage composition. Weight by weight, W by W. Mass of the solid per 100 gram of solution. Therefore, 30% weight by weight HCl solution. How you can read 30 gram of the HCl in the 100 gram of solution. Weight by volume, mass of solid per 100 cm3 or ml of the solution. 3% weight by volume of the glucose solution. Always that particular physical units, whatever the percentage composition is that mentioned in the bracket, like the W by W, W by V or V by V. 3% glucose solution is there, that means 3 gram of the glucose in the 100 cm3 of solution. That may come for the MCQs. Okay. Then the volume of the solid in 100 cm3 of the solution. 50% V by V of ethanol solution. That means 50 cm of the ethanol in the 100 cm of the solution. Then the chemical units, that methods. In this method, mole of the solid are either expressed per unit volume of the solution or moles of the solid per unit mass of the solvent. That is a weight basis or a volume basis. Then concentration on volume basis, it represents the moles of the solid per unit volume of its solution. That may come for the MCQs. There are the molarity, normality and the formality. Molarity is nothing but the number of moles of the solid dissolved in the 1 liter or say DMQ of the solution. That may come for the MCQs. 1 molar solution is defined as the solution which contains the 1 mole of the solid per 1 DMQ of the solution. 1 molar solution. Okay. Expression for the molarity. Molarity is the mole of the solid dissolved divided by the volume of the solution in the DMQ. Moles of the solid is equal to mass of the solid in gram divided by molar mass of the solid in gram. Therefore, mass of the solid in kilogram divided by molar mass of the solid in kilogram. In short, you will get this equation: M is equal to W by M into 1 by V. Molarity of the solution also expressed in terms of the millimoles of the solid per milliliter of the solution. Here the numerical is there, that is based on this particular thing. 2.4 grams of the sodium carbonate is dissolved in the given dissolved to give the volume to 4.5 cm3 per ml of the solution. Calculate the molarity of the solution. Atomic mass of the sodium, carbon and oxygen is given. W is given 2.4 gram, V is 245 cm, and they ask the molarity of the solution M. Molarity is nothing but a moles of the solid in gram, volume of the solution in gram per mole or say dm cube. M is equal to W by M into 1 upon V. Molar mass of the solid, we have to calculate Na2CO3. 2 is into the mass of the sodium plus mass of the carbon plus 3 into mass of the oxygen. Then 2 into 23 plus 12 plus 3 into 16. Then molar mass of is the 106. I'll put you all the values in this formula and you will get a molarity is equal to 0.0924 molar. Then the formality, one formal solution is defined as the solution that contains one formula weight of the solid in 1 DMQ of the solution. Formality is the number of formal weight divided by total volume in the DMQ. Amount of substance in gram divided by formula weight. Here just F is equal to W by F. Formula weight we have to take. Formality is conveniently used in case of the acids, bases and the salts due to their dissociation. Consider the dissociation of the simple monobasic acid in the acetic acid. CH3COH gives you CH3COA plus H plus. CH3COH is equal to 1 minus alpha into C. H plus is equal to alpha into C, and alpha is degree of dissociation. The molar concentration representing the undissociated acid will be 1 minus alpha into C. Therefore, when the formal concentration is providing, it gives information about how the solution is originally prepared, but doesn't deals with what happens to the species after the dissociation. Example, dissociation of salt like the Al2SO4 thrice, okay, then Fe2SO4 thrice, NH4 twice SO4 plus 24H2O. Here you have to calculate a formula weight, and then you have to put it here. See, 50 gram of this particular Na2SO4 10H2O sodium sulfate are dissolved in 100 cm cube of the solution. Calculate the formality of the solution, molarity of the Na plus and SO4 2 plus ions. Here see, Na sulfur and hydrogen oxygen, the weight molar mass is atomic weight is given, atomic mass is given. W is equal to 50 gram, V is equal to 100 cm cube, that is a 0.1 dm cube. F is formula weight is nothing but we have to calculate. Once you calculate the formula weight, formality is equal to F is equal to W by F into 1 upon V. W is the 15 divided by 3T2 into 1 upon 0.1. The formality is a 0.468. F formal. Molarity of the Na plus and SO4 ions. The salt in the solution dissociate as Na2SO4 twice Na plus plus SO4 2 minus. Formality of the salt solution. The molarity is given by, molarity is equal to 2F. Molarity of Na plus is equal to 2F, which is equal to 2 into this, and molarity of sulfate is 1F, that is 0.4658. Simply, here you can see. Then normality. This we will see in the next lecture. Here we will stop. Thank you.